In the previous video, we talked about static and dynamic libraries in C++. And as a short summary, we understood the fact that linking for static libraries happens during compile time. And on the contrary, for dynamic libraries, linking happens at runtime. And then we said that usually static libraries have better performance because all the instructions are embedded into the final executable files. And in return, it means that basically the file size of the final executable file is going to be larger. And on the contrary, for dynamic libraries, we said that the file size, the final executable files is going to be smaller, but then we're going to have a little bit of performance penalty due to the runtime overhead. And finally, we touched on the fact that maybe it's a better idea for us to work with dynamic libraries because of the fact that it gives us a lot of flexibility in the sense that if you update a library, then we only need to compile the library itself, and we don't need to compile the whole project. But today, I'm going to talk. I'm going to talk about another very, let's say, important practical aspect of developing our project, and that is the idea of using the powerful tool GNU Make and the concept of Makefiles. But before diving into the concept of Makefiles, let me talk about the problem or the issue first. We have seen this issue already in the previous video, but I'm going to do it again so that we vividly talk about it. With the new structure that I have right now, I have my binaries here, include here, libraries here. If I want to compile main.cpp, of course I jump here and say g++ main.cpp, and then my include directory is here, my libraries are going to be in lib, and the library I am interested to link is lib-runge-kutta, and my standard, of course, before I forget it, is standard C++11, and the output I want it to be in bin directory, and I want it to be called as a.out, right? So take a look at this. This G++ sort of command is getting lengthier, and it's getting more complex, and it's getting out of hands. And soon you notice that if you add more stuff, more libraries, more header files and stuff like that, then you know that this keeping track of this thing is not going to be easy. You cannot memorize it, you cannot safeguard it or put it somewhere. So there needs to be a solution for sort of automating the process of compilation for us. So now you sort of get the idea of why do we need Makefiles. If I hit the return key, by the way, I'm going to get my executable. If I go here and I can try and test it, and it works. Okay, coming back here, I can make a Makefile just by typing Makefile, or I can also use capital M. Both of them work fine. I'm going to stick with this one. So let's go inside. Let's talk about the idea of, or how, let's say, Makefiles work. They are pretty much similar to cooking recipes. Imagine I want a dish, like something like scrambled eggs, let's say. What ingredients do I need? Of course, I need some eggs, some oil maybe, and then some spices, pepper, salt, and stuff like that. How do I cook it? I say, okay, put the pan on the stove, and then add some oil, and then heat it up, crack eggs, and then add spices, and probably wait for 5 minutes, and then you get your dish. So you get the idea. Here I have my interesting dish, and here I have my ingredients, and then finally I have my recipe. The same way in the context of C++ and programming, it's going to be always we are looking for a target, and then that target has some dependencies, and then we're going to have our compilation recipe. So I'm going to keep this one up here so that we know what we are talking about. So what is my final target when I want to compile the whole project? Of course, it's my a.out as my executable, right? So I say a.out is going to be my final target. What dependencies do I have? Of course, I need lib-runge-kutta.so. And I also need main.cpp, but this is not really an ingredient because main.cpp is always going to be in my project directory, so I can remove it. It's not actually a dependency. So G++, And then what is my compilation recipe? Is G++. I can actually paste it here. I had it from the terminal. So this is how basically it works, right? But take a look at this. LibreKutta.so is a dependency. It's an ingredient, but it's by itself, it's raw. It's like raw fish. So if you don't like sushi, you need to cook it up, right? How do I cook it up? I say LibreKutta.so is going to be my new target now. But what dependency it has? Of course, the object file. And how do I make that? I say, if you remember, this is a shared or dynamic library, minus shared, minus o, lib-runge-kutta.so. And then, of course, I need to feed my object file to this. And in turn, runge-kutta.o, the same way, it's going to be another new target for me. And it doesn't have any dependencies because it only needs runge-kutta.cpp, and I always have it. So I can skip this. I can say G++ minus F pick and then minus C, and then I'm going to feed my runge-kutta.cpp, and then I'm going to get my output as runge-kutta.o, right? So things to notice. A.out is an executable. So a target can be an executable. lib-runge-kutta.so and runge-kutta.o are both files. So a target can also be a file. But there's another category of targets which are a little bit special. They are functionalities. They are not files. They are not executables, but they are functionalities. What I mean by that, let's say we have compiled everything in our project, and now we want to clean our project. We want to get rid of our binary file or our, let's say, intermediate object files and stuff like that. So I type here clean. This is my, let's say, target. Do I need any dependencies? Not really. I just want to remove my bin a.out, the binary file. I want to remove my library. And I also want to remove my intermediate runge-kutta.o file, right? I save this, and this is special category of sort of targets is called phony targets. The way we mention them is like this. I say dot and then phony, all in capital, and then colon, and then I mention the name clean. So another thing to notice, or a little slight modification here, I always forget to put the standard. Of course, here standard should be C++11, but that's not the point. The point is, these instructions are going to get executed in the main project directory. So this means that runge-kutta.cpp doesn't reside there. It resides inside the include directory. And in the same way, the object file, we want it to be in the include directory. Whoop. And then the same way, this one needs to be fetched from include directory. And this thing is going to be in the lib directory, right? So now if I go and remove all this nonsense up there, if I save this and then go back to terminal, check this out. If I say make and hit the return key, you see that make is so smart that it starts first with the object file by compiling runge-kutta.cpp, and then it constructs a library out of it, and then it tries to basically figure out how to compile main.cpp and then also link this to main.cpp, to the final executable. So now if I go to my bin directory, of course, I have my, again, I have my executable and I can test it. But now if I don't want these stuff, I simply say make clean, and this was my functionality. Now if I take a look at my bin directory, there's nothing there. And if I take a look at my lib, there's nothing there as well. So let me show you another thing. Let's say I compile everything again. Let's say I go to my include directory and I say I want to add a feature to my runge-kutta.cpp. Just like previous time, I want to add something like, I don't know, hello, for example. I want to add this. I want to save this, and then I come back. Right now, if I say make, I know that main.cpp is also going to get compiled, right? So, and then we said it's going to be dumb or dubious because we are using dynamic libraries for the sake of only compiling or only updating our library, not compiling the whole project. So this doesn't work right now. If I go back to my Makefile, the same way that I created my clean phony target, so to say, I can make another phony target as update rungeKutta, for example. So is this a file? No. Is this an executable? No. Then it's a phony target. What dependencies does it have? Of course, it depends on rungeKutta.so. If I say that and then I come down here, I add this one to the list. So this is going to be another phony target. And now check this out. If I say make update rungeKutta, then voila, only these two G++ commands are going to get executed. So this means I updated my library, but I haven't compiled my main.cpp. So now if I go into my binary directory, so this executable is the old executable file. If I run that and I test it, I see that everything, the changes are already made into this executable, right? So there we go. This is, let's say, Makefiles explained in simple words. And now you sort of see the power of using Makefiles, because now you don't need to keep track of all those complex G++ commands. You just come to the terminal and say make, and then everything is going to get compiled, and then you say make clean, and everything is going to get erased. So I hope you learned something from this video as well. Hope to see you next time.